two more students waiting. Let me let them in. Okay. Decline. Now, one more. Okay. All right. Hello, everyone. I think you already get the notice that I already post the project one to the Blackboard. Please download your parameters to do the simulation. Let me see. Before I go other things, I'd like to share the screen so you know what I'm talking about. 1 second. I go screen 3. Share screen. So I have this. Here's a little bit background about FCC structure. This project, we do Monte Carlo simulation about the melting of FCC crystals. So first, I want to, maybe you already know what's FCC structure in other courses, but I will quickly go through it. So FCC structure, if we go look at how it is stacking, so this layer by layer. If we put the these balls carefully, is close. I mean, it's closely stacking together. They are touching each other. You will see. So yeah. So for one layer on the table is touch. These balls are touching each other, form one layer. Then you get another layer on top of it. You will see it's better these balls will go to the the center of their gaps. So the second layer will be to fall on this middle. So these triple points. Go to the triple points. Then this second layer. For the third layer, is better because of C. If we go to another triple points. So the triple points of the touching of middle of the three balls. So you will find that it have a sequence. So A, B, C, it will goes in the same way, it goes to A again. So A, B, C, it have such a stacking. So I'd like to mention that that's how we get this. There's lattice constants. This A relationship with their diameter. This diameter is the radius R. The diameter is 2R. And this 2R actually is the minimum in there's it's a minimum in their is a minimum of their distance. This Lennard-Jones potential, and if this sigma here, sigma is the minimum distance, nearest labor, let's see, during the equilibrium. So from here, you will get the relationship. If I have it somewhere, let me see. I write it somewhere. 1 second. So let's see Monte Carlo and project 1 and ours project. Wait 1 second. So we need to it's opening. Where is it? 1 second. All right. So I put it here. So if we count the diagonal, we count the diagonal. The diagonal is 4R is 2D. And it has a relationship with the lattice constant A is square root 2A. So we will have this. We have a knot is lattice constant of a FCC structure is square root 2 of the diameter. It's also because diameter is R minimum. It just showed this has a relationship with the sigma. The Rm is a minimum, has a relationship with sigma like this. So we will have a relationship of the lattice constant with the sigma. So there's this important number 1.5874. I already generate these 5 configurations. So I already put it in the Blackboard. These 5 configurations, 3 by 3 by 3, 4 by 4 by 4, 5 by 5, 6 by 6 by 6, 8 by 8, etc. So you need to study the system size effect. So we will start from the small size, this 108 atoms, this minimum, this FCC structure, and you will do the 5. 1, 2, 3, 4, 5, 6, about 6 structures. You need to study these 6 structures. And what you need to do is, let me open the one. So say so you will, yeah. So you should do the system size effect. These 5 structures. So for the 10, maybe calculation is too large. So you can ignore that. So 3, 4, 5, 6, 8. What you need to do first, you need to do MVT ensemble, Monte Carlo simulations. You use the smallest cell first because it's easier. Our test, you will see if you do 10,000 Monte Carlo simulation, it will do, you take only 0.1 seconds and it will finish very quick. Just use a single core, right, in your notebook. In general, it take 10,000 Monte Carlo steps to have equilibrium. Then you need to take 100,000. This about it will about 1 second to finish. You do this to take the statistics. So this data is valuable. So you need to take that as stat. Then
Okay,
yes.
Yeah. Isn't it suppose like the minimum number or the steps we should do is Avogadro's number?
Yes, there's a minimum. More or less, first you need to find what the equilibrium steps. Because if you have a larger size, you will see the curve. Sometimes you need to judge from the curve. Right? You will see it will decrease or increase at the beginning, then it will fluctuate. You know that when the fluctuation around average, you know you're approaching the equilibrium. You do the statistics just after equilibrium. I'd like to tell you that for Monte Carlo simulations, in this size is really quick. One calculation is just a few seconds. So you need to one by one, etc. So first you need to plot the total energy as a function of MC steps, right? So you can spot the equilibrium. Then you do statistics, etc. So for the melting temperature, please plot the curve of the cohesive energy. You can count this as total energy divided by the number of atoms as a function of temperature. So you will see, as I showed in the class, there will be a jump during the melting, during the phase transition. So this for MET ensemble. And then we will, once you do this, one side, you do other sides. So this one. Then you need to plot the transition temperature as a function of size. You'll see it's change a little bit. You need to find out. Then Solari talked with me that we need to minimize your efforts at the first project. So for the MPT ensemble, just do one pressure, like 0. So you just do one pressure. And you need to vary the temperature. At that time, the volume will change. So you need to plot two things. First, the cohesive energy as a function of temperature, and second, the density as a function of temperature. Later, you also need to plot the RDF, radius distribution function of two phases. Before the melting and after melting, you will find the very different behaviors of these curves. Yeah, there's something I'd like to mention about our project. So please follow the instruction and finish your reports. So do you have questions so far?
Doctor.
Yeah.
In the first step about the Monte Carlo steps, you mean we need to change the steps in the control?
For the one system, you do not need to change. But for if you change the system size, you need to do a little bit change. I'd like to say for one system, you do not know at the beginning, you don't know which size, which with the MC steps is good enough. You need to plot the energy versus steps. You will see, you will spot the equilibrium. You will find it. I may give you an example. All right, I'll give you an example. Say, let's see if I have it here. Say, I may not be here. I will give you an example about my recent study. So it should be, I forgot where the location is too much. Yeah. Is there any other questions? Otherwise, I will find, in the meantime, we'll find it. So let me find the examples. Programs, DL multi. Masters, exercise. So for example, you can do, you know, for the safe, I do all these tests. So you can use to have a look, whatever. So this one is easy one. This size is small. Yeah, I need to show you that this orbital, you have to control the size. How to do that? You click in the right side, there's a control panel. So you will select the particle size, particle types, and here they use a radius 0. This means very large. I mean, because you can say 0.2. If we put in 0.2, let's see, I forgot the temperature. But yeah, we see it's more or less, this becomes amorphous. Yeah, we see from the beginning is beginning is more or less crystal, but later it becomes amorphous, melt. And this is something, and stop here. Yeah. I'll show you if I have, so this 1B. I'm showing the energy plot.
Doctor.
Yes.
I have a question about the plots.
Yes.
You showed us how to plot just one file, energy. How can I choose my function, what I want to plot?
Okay, that's a good question. Last time I showed you how to do the plotting in Python, right? So let me.
Yes.
From the very beginning, let's see spider. Maybe too many programs opening, but anyway, it's coming out. Yeah, if we use, wait a second. If we use our, original auto save. Let's cancel. All right. Last time I already showed you, we have energy data. Right? you can easily to plot it. Just use 3 lines, right? First, you import PyLab as a PL, then you load the data, pl.load text. Then you do the plotting. Once you do the plots, it will just shows here. But you need to put this script in the same folder of your data. That's easy. So this previous test, you will see it's not that good, but you see it have not been equilibrium yet. So you will see this such kind of decrease. That because I use what? I use the tutorials, the tutorials data. That data is not well equilibrated. For the data file I gave you in the Blackboard, that one already achieved their minimum. So that you will see it's easier to go to approach the equilibrium. That's something. So your question is how to do the plotting. You will see roughly, we can easily to see the curve just in 3 lines, but later you need to change, say how to add the X label, for example. We can do this X label. So you'll see MC steps. We like to say that. And Y-axis, we like to put it as Y-axis. You need to put that energy, for example. You can do that later. ENERGY, say EV or whatever you need to find out your units. Then you will see it shows immediately, yeah, MC steps and energy. Say whatever I'd like to calculate the cohesive energy. So the energy I need to know the number of the atoms. So here the number of atoms is 512 in their tutorials. So what I need to do is I need to divide by the n. You see the number of atoms. And here you say we do cohesive energy. So you do the plotting. And you will see you get cohesive energy versus MC step. So this you need to do. And another thing is, say I'd like to change to another sign, like ROL. R means I want it to be a red, not just the blue or whatever. I want it's red. It's in line. I also want a symbol of spheres if there's a data. You can also easily do that. You see? Okay. You can also plot multiple. So we have done one day, this for one temperature, we do another. Then you get all the data, for example, energy 1, energy 2. You do the same noding, but your node with M1, right? It will say node M1, energy 1 to M1 data. So if we have another, right? For example, if say I have an energy 1, then we node it to M1. Then we do the plotting, do the same. Then it will shows side by side for comparison. So I hope you guys can do that, yeah, for different temperatures. Then you will mark the different temperatures for this. Each temperature you will find, you can use different color to do that, or symbol. So in this way, you can have a very beautiful plot for your report. So do you have questions so far for this?
So Dr. Bing,
Yeah.
do you just add within the same pl.plot M and then M1, and then you would comment, let's say, a black O minus, and then like you plot it in the same line in the same command, or do you write a new pl.plot?
It will, let's see. All right, let's do a test. All right. So let's see the same file. I will note it again, right? But I plot it in a different way. For example, I will do a model, do a little bit change. For example, say I will change the energy. Change the energy. I will add a constant. For example, I will add, for example, say 0.2, all right? 0.2, not this one. So plot 0.2 times 512, because later we will do the dividing. I will copy this later. Just for the demo, all right, video demo instead. So now we do another plot. Say we do plots. This is M1 X, also M1 Y. So we have this. Now we can control it. Say we can BD. B means diamond, or you can use a square. You can use dash line. Okay, that's easy to do that. So, okay, we have two curves. Let's see. You can easily to plot two curves in one figure. Right? We just do a shift a little bit. But if you have a different say temperature, then you can easily to do that. For example, if suppose the red one is T1 and the blue one is T2, what you can do? You can do this L1, which is 9-1 equals this, and you say LABL label. Label what? Label is T1, temperature 1. Right? For the 92 equals. Yeah.
Are you on Spider or the screen is frozen?
I use the Spider. I think you guys should see what I'm typing, right? No?
I don't see any typing. I only see Spider with till line 5.
Now I have 9:14. Yeah, it's strange. Yeah. Let's see. Maybe I should increase the size.
I only see till line 5. I don't know it's frozen or there's something.
No.
Because I see the mouse for you and it hasn't moved.
For me to work, maybe you have to quit and enter again. Maybe it's from your side, it's frozen.
Okay.
Okay.
Anyone else? Is it frozen for anyone else or?
No, it's good here.
Yeah, it's good. So maybe you have to quit and enter again.
Okay. Yeah, please do that. Okay, I add another line, so pl.legend. So in this way, it will automatically add add the legend, table 1, temperature 1 and 2, for example. Let's do that again. So you will see it automatically shows something here. So temperature 1 is this line, temperature 2 another line. So that's the, so you'll find it super easy. You can easily to do that. So this spider is very convenient. Wait 1 second. And I hope you guys can plot the temperature like this. You have all the, you will test at least 6 temperatures. So 3 in the solid state, 3 in the liquid state. So you see how the energy changes, but eventually you need to get equilibrium energy. So you will get that and plot it as a cohesive energy versus temperature. Then we will see there's you will see there will be there's a jump, so we can find it if I from other. So I'd like to see the energy as a function of temperature. You will see there's a phase change. You need to find this critical temperature. Right? You need to do Monte Carlo simulations to find out. Maybe next semester you do MAMS, you do molecular dynamic simulations. You may do something similar, but we'll see, find that. Also, you can spot there's as I showed you, right? So if the temperature is high, then it will be liquid. If it's low, then it will be crystal. You will find the difference and show me that. Also, you need to plot the radial distribution function, same as what I showed in the spider. You have you can input multiple data and plot it in one figure for direct comparison.
Dr. Bing?
Yeah, what's the question?
So it's a general question to understand Monte Carlo. So when we change the temperature, are we changing the number of random walks or how fast the random walks or random dots occur or steps?
Now it will. You do not from the control panel. You just need to change one parameter. That's temperature. For the others, the system will automatically adopt because we already set the acceptance rate. They will do the change. If I can show you on my basic, okay. I go here. So sorry, it's kind of slow. So let's see, we go to here. I just show you a little bit. Let's see how we do the temperature. Let's go to the smaller ones. So in your control, right? Each time you can easily do that in your control. You can see have a place to set your temperature. You can easily to do it because just now I showed you, you will see it's more or less like a melting because we do it at temperature of 3. So if we do it at 1, you will see. Let's save it. Let's say let me show you how to do that. You make it a temperature 1B 3 by 3 by 3 system, and 2. We have another test. So let's copy whatever we have. So I just in the previous one, we have 3 important input, right? So you need to field, we need to control, whatever, and we need to config. So we copy these 3 files here. And wait 1 second. Maybe I should use another. Say, I have a workstation called a PP. If you guys say my computer or my notebook is really slow, I'd like to speed up the project, so you can email me. I can make an account for you. Okay. So, and do this. And I go to the same directory. All right, so I have this all in my file. Sorry, I should make this larger. I use all the same. You don't need to do. You just in the control. In the control file, we can change the temperature to 1. From my previous experience, for the 1, it will be a crystal. So you will see we set a maximum displacement for each movement is 0.1 angstrom. Then acceptance rate is about 0.37. I don't know what's wrong. So you will see it will automatically change. So acceptance rates will be around about 37%. So what you don't need to kill this too much right now. You just leave it as setting. So you just do the testing. Now we do, for example, we do the calculation. You will see less than 1 second. All right, you will find it finished. That's about we can tail output. Yeah, 1.5 seconds. Easy to do that. So after doing this, you have 2 things to do. First, you look at your structure. You look at your structure. I will go to this one. So we look at the structure. So you will see it's up. As I told you, go to the particle and change the radius. So 0.5, maybe it's okay. 0.5 is large. 0.2. So let's see its vibration. You will see it vibrates, but if it is still around the lattice size, it's not been melted yet. It's vibration. It's still solid. It's still in crystal size. That's something. Stop this. And it's easy to, for example, energy. In your QI, then you will have energy dot data. Then you just say, I want to plot it. We already have it. In your QI dot data. Then you say, I'd like to look at it. This one you will find is fluctuation around the minimum, so around the average. This is something quickly you can get. So you just need to change the energy. In 1 second, you have the results. You make a table and then plot it for your report, right? For the project. So questions so far? All right, so you're I already put the all the configurations, configurations file for you already. You just download from the Blackboard. I need to mention the one thing. For here, let us see. We have 3 by 3 by 3. This one, and from the beginning, you may know what I mean, right? From the beginning, I showed you there's a parameter 1.58, 1.6. This one, you will find it here. For example, I want to do more. So I just want the Python to do the calculation. What that means? Sorry, I did not copy this one yet. For example, copy this. And I paste it here to Sigma. I say I want to 3 times, 3 by 3 by 3, right? So the cell size, you will see how this number come from. This number come from because we use a 3 by 3 by 3 lattice, and each lattice, they have a lattice constant, 1.5874. So eventually we have the lattice vector. This one, the other is 0. So this is orthogonal. I'd like to mention that from the question I gave you from the project, each of you will have a different number. Each of you will have a different number. I'd like to say maybe I have another. See. So you have a different number of I need to get that out for you. Wait a second. 1 second. So you have different number, different parameters, sigma, right? This sigma and epsilon. I need to tell you that For example, you have a sigma or sign for this number. What you need to do, need to change for your project is you need to multiply this. You need to multiply whatever I give you. You need to do that.
Doctor.
Number. Yes.
For us, it is we all have a sigma equal 1.
Now, yeah, if your concentrations, your undergraduate,
Yes.
I have a last requirements. Yeah, so you do not do that. So you do not need to change this part. All right. So you
Okay.
yeah, give it a little bit easier. Yeah. For the masters, you need to do this. Right? You need to change the lattice constant according to your parameter. So how you do that? You just put this one, take out, right? And you type your parameter or sign. So you have you need to do this. We have a new number. You copy it and paste to your config. So you need to do this. Eventually, you need to change these three things. For the others, you need to change the field file. The atoms position are in fractional coordinates, so you do not need to change the others. That's the thing you need to do. Each of you will have different parameters. You just type write and quit, so you will have it saved. As I said, each of you will have a different parameter. So each of you need to do your own, have your own data. But the method is the same, right? Method is the same. You will do your own, have your own report. Do you have questions so far? I will not change. So what do you do in your project? Right. So you need to actually modify, you need to build your own field file from the tutorials. So what do you say here? We assign your different number, right? This one is, this is epsilon, this is sigma. So you need to also change this sigma, not this one. Right. So we already assigned you, for example, you have your sigma is 1.05, you need to change it here. And then another number, you need to change it here. You need to have different potentials. Each of you have different potentials. Yeah, there's some hints. Calculation is easy. Each simulation, it takes a few seconds only. You just record and do the simulation and do the plotting. Any questions so far? Sorry. Yeah. Otherwise, I think almost the end of the session, the 6th, and we still have another students who have the problem of installation of Del Monte, and hopefully so Ubuntu. So if you do not have other questions, you're safe to leave, and I can spend more time for the students who have questions for installations. If you are interested, you are welcome to stay, but otherwise you are safe to leave. If you have questions, you have a chance to share, to ask.
Doctor.
Yeah.
Can you also just do a quick recap from the first step to the final step?
I did not get your question. What do you say?
Quick recap to the steps that we have to do for the project. Just a quick recap.
Yeah, for the project, you need to do different temperature, right? You need to check which temperature, they have. First, you get a low temperature, it's a crystal. Then you go to high temperature, it's melt, it's a liquid. Then you need to go to the middle to find out which temperature it do have a phase change. So you need to find out the critical temperature. You need to do that.
Doctor.
Yeah.
So how can I choose which temperature? I just choose on my own?
We don't know. You need to test. So at the very beginning, you start from low temperature. For example, 0.5, 0.9 or whatever. You can goes up step by step. That's your way. Yeah, I will not tell you the whole story. You need to test by yourself.
So
eventually,
if the system doesn't reach equilibrium, I need to add more steps.
Yeah, you need to increase the MC steps. You say you will in the control file. You will increase number. For this one, if you see this 10,000 is still not enough. So you say I go to maybe 20,000. As I said, you can go to 100,000. That's still very, just maybe 10 seconds. It's still very fast. You can do it. You can get the equilibrium. Because beyond this, it will become like a flat line of fluctuation, but more or less on equilibrium like that. So you need to find out when it approaches equilibrium. You need to spot that. Yeah.
Okay, thank you, Dr. Ben.
All right, thank you very much. Yeah. If you do not have a question, you're safe to leave. Yeah. I think there's some the students, they have a question about installation. This
Doctor.
Yeah.
About the extraction of the energy, is it the only file we're gonna study? So it is the only.
So you say the configure file? No, it's not. Configure is actually I do my favor, right? I generate the configure file. If you in the lecture in the class, I tell you how to generate it by your own. But I find that will be difficult for all of you. You guys may do not have time to finish the project. So I do that for all of you and I tell you how to scale it by your own parameters. So you download it, you just change that parameters, then you can use it, right? And just do that for you.
Use it in the spot of the config file.
Yeah, just for the config. But you also need to write your own other files.
Yes.
Like control, like a field, right? And this control on the field very similar to the tutorials. So I will not, send these files to you. Otherwise, you guys will not think much more, right? Please finish the first 3 tutorials. You will understand a little bit more about the what they are doing. Then you can easily to write that 2 files. Each file is only about 10 lines, not complicated.
Yeah,
you need to spend a little bit of time. Yeah.
So it is the name of the file. It must be config. Do I need to change it or keep it?
You need to keep it exactly. 3 files all are the same name. control, field, and
Can't change the names of.
yeah, config. Do not change the name. Do not change the name. Otherwise, the system will not recognize. They say your.
I mean the files you gave us, on the blackboard.
I give you to the blackboard. You need to copy. You copy, for example, your study is
Okay.
yes. You copy it to config. Yeah.
Yes.
Yeah. Need to copy to rename it to your config. Then you can do the simulation. Next time you do another system, you can copy, for example, 4x4x4 to config. Then you do the study.
Thank you.
Yeah, you're welcome.
Yeah, Dr. Bang, this is me, Ahmed.
Okay. Could you please share your screen? I think I already allowed you to do that. Let me stop sharing. Yeah.
Okay.
Wait 1 second. I stopped sharing, and you should share your. Be able to.
How do we do that? I know how to do it on Teams, but here I'm not sure.
It should be the same. Should be the same. Yeah, you just share your screen. You're already allowed to share. So,
Which?
do you find the button? Do you have found the button? If you see my camera, right? If you see my camera, at the bottom, there's a green line beyond the chat. Let's see, beside the chat.
Oh, yes.
Share screen, right?
Because it doesn't,
okay.
It doesn't appear in the minimized version.
Yeah.
Minimized view, yeah.
Yeah,
Thank
that's
you.
easy. Yeah, you're welcome.
Okay. So let's see. So it shows now, right?
Yes. Okay. I show your desktop. Then I think last time you say you have the difficulty to upgrade your system, your
No, that's another person. I think Khawla.
Okay.
I have a problem with, like, I go through the steps. It's okay when I get to compile a serial version, he says that a certain file is missing.
Okay. So please repeat what's your error message. Yeah. So please add and show me your error message so I can help you.
Sorry, what error message?
So I say now have you installed the DL Monte?
No, this is the problem. I go through this, and when I get to the
I request the control.
I accepted.
Yeah. So please go to the DL Monte, this directory.
Where the file, you mean?
Yeah, the file. Yeah.
Yes.
So okay, this release master. Okay. So in your Ubuntu system, can you access it?
Yeah, here it is.
Okay. So where's DL Monte? So can you please CD to there?
So CD Del Monte.
Yeah. CD.
Yeah.
Yeah. Okay. LS. And you list the directory. LS. Yeah. You have nothing there.
Yeah,
well,
but when I follow the steps, right, let me show you from the beginning, the whole thing.
Yeah,
so
okay.
let's just follow the steps one by one.
Okay.
So
yeah. make it program, CD program, great. And yeah, make it dir dl Monty. You already have, yeah. So dir Monty.
Let me just copy this whole
Yeah.
thing.
Yeah. wget, easy, just few seconds. Yeah, you follow it. Okay. Yeah, enter. Good. You can split the screen as I showed you last time, right? You split the screen side by side. See you will say. Do you know how to do the screen split? Use your keyboard, right? You
Yeah, the
have Windows
with,
key. Yeah.
The Windows key with what again? Sorry. Windows
So
and down.
It's painful. Yeah, you should split your screen. Split your screen. You know, split your screen. Use your keyboard. Your keyboard.
Yeah, Windows and up.
Yeah, Windows key. Windows key.
Yeah, I know.
And you have the arrow. Then
it's just
then you're no. You use the arrow. Yeah, side by side. Yeah,
okay.
Exactly.
Okay.
Exactly.
Yeah. Okay.
Yeah. Then it's copy, right? It's safe, right?
yeah. It's
convenience. Do not do other way, all right? Just do it side by side. Yeah. Yes.
Now the issue becomes because
okay. This is something I'd like to show you. First, I'd like to say, could you please do sudo apt install cmake? Maybe.
Sorry again.
Okay. Wait 1 second. I got sudo sudo blank, right? Blank space and apt. Yeah, space. Install. Yeah, space. Yeah, cmake. Yeah. It's fine. Just cmake.
Like this.
Yeah.
Enter.
Yeah, enter.
Okay.
Sudo must be owned by. You have an issue of sudo. How this happen?
I don't. I uninstall it and install it again. Try again. Same thing.
No, I think the last time reinstall and solved the issue, right? You delete this Ubuntu. Yeah, you delete this Ubuntu and reinstall.
I uninstall Ubuntu as a whole.
Pardon me? Yeah.
Uninstall Ubuntu completely and restart from the beginning.
Yes, you just do that. Yeah, just do that. You can do the whole process in 2 minutes.
It's not hard, but I didn't think the problem was with Ubuntu.
But it will remove this issue, right? I think once you have do that, you will be sudo. Otherwise, it doesn't make sense.
So I should just uninstall Ubuntu and reinstall it and Ubuntu. Start from the
uninstall Ubuntu. Do you know how to do uninstallation?
Yeah.
You just go to Windows, uninstall.
I did it before.
Okay. Yeah, remember your name. Yeah, once you do that from the fresh, you will have the sudo. You're the owner. You're the owner of the whole system. So this doesn't make sense that forbidden you to do any change, right? So you are the owner of the whole system. You should have the permission for any change. Yeah. Otherwise, you will have further troubles. Yeah.
Yeah, I will try to like reinstall it and see what.
Yeah. You need to reinstall. It just take minutes.
It doesn't take time.
Yeah.
Okay,
please go ahead and do that. Once you do that, you install the CMake, and then later you will do something like that. You will keep that. If you keep that in mind, you see we just sh build. Sorry, sh build build. I already showed this a few times in the tutorials, in the video tutorials. So you just do this, then it will automatically do that. Many things, combination. Yeah, something like that. No such file, this means you cannot compile. So you need to have something, you need to install the things. Before that, you also need to install sudo apt install open MPI bin. You need to install this. So you need to have the root. You need to have such permission. Otherwise, you many things. You have a lot of difficulties. Yeah.
I will reinstall it and see.
Yeah, please.
What happens?
Yeah.
Hopefully it works.
Yeah, please do it ASAP. Otherwise, you have no time to finish your project.
Yeah, we'll try to do it ASAP.
Yeah. Pay attention. Yeah. All right. Please stop sharing and let's go ahead to work on it at your weekend. Yeah, please beg others to help you. Yeah, if you have, you need to pay attention a little bit, and then you need to post your questions to the group, and others may help you. If not, then you can come to me. Eventually, you can have it solved. All right.
Okay, thank you.
Please spend the time on that.
Yeah, all right. Thank you.
Yeah, you're welcome. Yeah, the others, other questions, please stop sharing.
Yes, Doctor.
Yeah, please.
Doctor, I sent my problem to Telegram. I try to update my Ubuntu from 17 to 20. Then it will be updated to 18. Then my laptop, I can't open it, and only I see the terminal. And I got this message.
Can you please share?
Enable? Yeah, and I can't because I enter from my Mac, but there is another laptop.
Okay. Could you take a photo? Use your cell phone and post it to me like a Telegram.
Okay. And I got the message: enable to correct a problem. You have held a broken package, and then I sent to you the solve for this problem, and I tried to enter all of these commands, but there is nothing happened to me. And I try this one.
Yeah. I know you guys do not have previous experience. They will have tremendous difficulties. Yeah, please paste. Let me. I just have a problem with my PC and I had to restart it. Okay. Please send me the photo so I know whatever you have difficulty. I saw it. 1 second. Did I get one?
I sent it to you in Telegram.
Yes, I saw it. Yes. Okay, let me have a look at this. Okay, you can't start even.
I can't open my laptop. There is only a terminal, and there is only I can write the comments.
I see. I see. A second, and then go to Lex. This one is not that clear. So you have, okay, you have something, let me double check. Sudo configure a, okay, so it's not upgraded. I think you should, you should use the command called start X. If you just have the command line, you should use start X.
Yeah, I try it in the morning, and there is nothing happen.
Yeah, you could start X. Then it will start the Windows system. Okay. If it's not, so this one was the version. You upgrade to 20 already, or?
I had before 17. Then when I upload it, when updated, it will be 18, and it's work. Then I want to update it to 20. When
20. I see.
When I try to update, I got this message.
Okay.
There is you have healed the broken package. Then when I try to do sudo dbkg set selection, I get the name of my package libc6. Then I would like to remove it, but I can't, and I have now 272 program package. There is not no, there is upgraded.
I see.
Maybe I have to remove it, then update my Ubuntu, right?
Yeah. You mean,
but I have to write the name of the package.
Okay. Yeah, you need to find that sudo apt purge. Yeah. There's a large community of the Ubuntu. You just type your error message, and you'll be find answers through Google. But I know what your difficulty is. So any other notebook? Do you have any other notebook, or this is the only one you have?
I have MacBook and this one HP.
Okay.
And this week, all day, I try to solve it, and I try to research about solve, and try all of the comments, and there is and actually I'm afraid because the Thursday it's near.
Yes.
I have to finish my project early.
Yeah. May I ask? Do you have some important data on this system? Maybe not. If no, you can start from the beginning to install 2004, like a fresh installation.
Okay, what I have to write now?
Okay, and that's.
Or if you have like a website, and then I follow to.
Yes. Wait 1 second. I will give you the website. How to.
Yeah. Because I put all of my files in a Google Drive, so that I don't worry about it.
How to generate bootable USB bootable 2004 USB from, you have a Mac, right? You have a Mac book?
No, but in Ubuntu, I use HP for Ubuntu.
Okay, wait 1 second.
Okay.
You will find this is very useful. I do this, I install it many times. So it's better to have a fresh installation. You're still there, right? I type.
Yeah.
I type.
Okay.
And they comment. I make better to type to your Telegram, so that you can better to have it in other place. So this one tell you how to have a USB. Yeah, I burn USB many times. Yeah, so you have a USB drive, then you have a disk. We do not use CD anymore. We use stick. You download the installation package. The website of Ubuntu. That's about 2 gig, 2.4 gig. And you burn the ISO file into the USB. It's easy, all right? It's just a few minutes. Then plug in your USB to your computer, say start from the USB. Then you install the totally new system and it will overcome your difficulties. This one.
And when I follow these steps, I have to remove the Ubuntu like a new laptop, or I don't know, or I don't have to do.
I think if you have this one, you can install it as okay. So right now, Ubuntu is the only operating system on your computer, or have multiple operating system?
What do you mean?
You said you have a HP, right? HP computer, right?
Yeah.
So do you have Windows on it, or just have Ubuntu?
No, I have Windows. I can open the Windows, but the Ubuntu, I can't open it.
Okay, so do you have Windows, Microsoft Windows system installed?
Yeah.
You already have. Okay, good. Then you can. Okay, let me see.
You mean I have to enter the Windows and I use the Flash?
No. Yeah. You can,
because
you can use flash drive as an operating system also. You can use another choice.
Yeah, but I have the held package. All the you mean I don't have to remove it?
It's a little bit. Okay, let's see how what the situation we have. You have HP computer. From my understanding last time, you only have Ubuntu on that, right? You have Ubuntu.
Ubuntu and Windows.
Oh, and the Windows.
Yeah.
So the Ubuntu is inside Windows or side by side? It's dual.
Side by side.
Side by side. Okay. If it's side by side, then you can say if you have this new system. You can say once you install this new operating system, you can just remove the whole Ubuntu. You just
I understand, but how can I remove remove the old Ubuntu?
Yeah, once your installation Ubuntu, it will give you the option. You install side by side, or you remove the older one.
So I have to choose remove the old one.
Yeah, you need to choose. Or you can say if it's important, you say side by side, like Windows. Okay. Do that. Yeah.
Okay.
Yeah.
Yeah, I understand. Thank you.
Okay. Yeah. Another thing is do not be panic. All right. If you all the options went out, I can open accounts in our server. So you can access the server and finish the project right now in this week. Then after the project, you can continue work on that or whatever. So just do not be panic, be crushed. All right. So we have other options. Right? Just let you know.
What do you mean? Where I have to work in this weekend?
So if you say if you still cannot solve this new system by tomorrow, for example, tomorrow, say 5 o'clock, right? You still have not solved that. Yeah, I can create an account for you in our server. So you can, for example, can you see my desktop? No, I have not shared it yet. Yeah.
No, I can't.
Let me share you. I need a bit. So 1 second. Let me share. I share the screen. You see my screen, right? So
yeah,
we have a system. We already have a system. So I can create an account for you. So you can use this system. This system, I already have it. So if you see this PPE workstation, so you can access once I create an account for you. So you can access. You're outside. You're off campus, right?
Yeah.
Okay. So if you're off campus, you just do this. You can access the workstation easily via this SSH. So you can this SSH can from Mac, from Windows, it's easy, right? So you can have even for the Windows, you can have PowerShell. What else? If you're on the Windows.
Yeah, you mean it's like a supercomputer?
Yeah, I have we have a supercomputer here. You do not need to use your own, but this is the backup. Yeah, sometimes I hope all of you have your own computer Ubuntu work on, but if you're have very large difficulties, do not be crushed. All right, just we have some options, so you can use this one, so you can still do the job, do the simulations.
Yeah, I think it's better than.
Yeah, that's good. Yeah, that's
maybe because it costs more.
Pardon me?
Because it costs more for the university.
No, it will just cost my time. That's all.
Sorry.
So if every students come to me, I do not have much time to work on this. Yeah, but just a few of you, then I can handle. Yeah, so it's fine.
Okay, thank you. Yeah. Okay, I will try this for memory.
Yeah. Try yourself. Then if you have something by your own, then you have a toy to play with. You have a lot of flexible, to do that.
Yeah. Okay.
But I just tell you, do not be frustrated. We always have alternative. We have plan B. This is a plan B. All right. So for this.
Okay, thank you.
Yeah, you're welcome. Yeah, please let me know if need an account. Right.
Okay, thank you. Bye.
Yeah, bye bye. Thanks. Bye bye.